This is one of the few places in our solar system where we have a good chance to look for life. There's evidence for a vast subsurface ocean below the icy crust of the Moon. The amount of water that's suspected there is many times more than all the oceans together we have on Earth. On the poles, you're approaching minus 200 degrees Celsius. Icicles that could be several meters high might be present. And if you're very lucky, then you might just spot a plume erupting nearby, like an ice volcano that ejects material from the subsurface to enormous altitudes. On top of that, there's a good chance that there's an energy source at the bottom of the ocean, hydrothermal activity, that can support the emergence of life. That makes Europa outstanding. Europa Clipper is the first mission that goes to the outer solar system that has the exclusive goal to investigate the habitability of the body in the outer solar system. It will launch in October 24 and will arrive at Jupiter in April 2030. So it's 5.5 years for Europa Clipper. Jupiter has like about 70 moons, so the number increases like every year by a bit. But there are 4 moons that stand out. That are the so-called Galilean moons. The innermost is Io, then Europa, then Ganymede, and then Callisto. With the telescopic observations before the arrival of the first spacecraft, you could see that some of these moons are really, really bright. They reflect way more light than a rocky surface would. And so, for example, Europa and also Enceladus, they are one of the brightest objects. And so it was suspected already at that time that the surface might be composed of shiny, reflecting water ice. I mean, after the investigations of the Galileo spacecraft in the late 90s, Europa became a prime target in planetary science all over the solar system. Because with a huge subsurface ocean, with the spectro-hydrothermal activity, that became the first place that could be habitable in our solar system besides maybe Mars. That immediately sparked proposals of missions to go back to Jupiter and specifically investigate Europa. I mean, if you are a planetary scientist, probably the most rewarding science goal is to see if a planetary body is habitable or actually inhabited. So Europa Clipper will stay in orbit around Jupiter, and in most of its revolutions, it will have a close flyby at Europa. And the flybys are arranged in a way that it's like a web in the end surrounding the Moon, that you have in the end a good overview over almost the entire surface after these 50 flybys. During this close flybys, you get an idea of what is evaporating from the surface of Europa. And from that, of course, you learn about the makeup, the composition of the surface. And this is, of course, specifically true if there's plume and venting activity. That's what I really would put a smile on my face, if we could measure plume material that's connected to the subsurface ocean of Europa. The instrument called SUDA, the Surface Dust Analyzer, is the instrument I'm working on. It measures the composition of tiny grains that are surrounding Europa, mostly ice grains. And these grains are knocked off the surface by micrometeoroid impacts. With the SUDA instrument, we can sample these materials, and with that we get an idea about the surface composition. We could constrain what salts were there in the ocean, if there's an alkaline, neutral, or basic environment, if there's hydrothermal activity at the bottom of the ocean, what the organic chemistry inside the ocean has evolved to. Unfortunately, we currently only have one example of a planetary body or a moon where life exists. And so it's very difficult to speculate about the nature of life elsewhere. If we look for signs of life on an icy moon like Europa, it's probably the most straightforward to just look for simple forms of life. If there would be complex civilizations in the subsurface oceans, we probably would have known by now, right? But I know that at least for the life on Earth, the access to oxygen is important to develop complex life compared to simple monocellular life. So this is one of the big science questions that Europa Clipper wants to answer. Has Europa Ocean access to oxygen that is created on the surface? So is material from the surface cycling back down to the ocean? If yes, then oxygen might be available in the ocean, and this opens up the possibility for more complex life. And not just a single cell, but maybe fish-like complex life. Everything between one cell or no life or fish-like life, like complex organisms that might be even intelligent or not, nobody knows. It's really up in the air. I look very much forward to the launch. It will be launched on a Falcon Heavy that was decided only a few months ago. So one of Elon Musk's rockets. And I'm really much looking forward because I never saw a rocket launch in my life. I like to see it. But on the other hand, it'll make me nervous. So that's always a problem. If rockets have a chance, even the safest rockets have a chance of like a 1% or 2% that there's some failure, and then everything was in vain because all the development has been done. Most instruments have been crafted twice, that you have a spare. So I really hope that the launch will go well. So I think it's one of the most exciting missions there is, and I'm really glad that I can participate in these endeavors.